Find d dx of x arc sine of x, and hence find the integral of arc sine x dx. This is a typical sort of a question. We're going to find this, and then we'll perhaps be able to rearrange it to find this. Now, here we've got x times arc sine of x, so immediately that should let you know that you have to use the product rule. So it's type u times v, where u and v are functions of x. The product rule, so we let u be equal to x, and differentiate that, we're going to get 1. And we've got v is equal to arc sine x. If we differentiate that, we're going to get 1 over the square root of 1 minus x squared. The product rule says d dx of uv is equal to u dv by dx plus v du by dx. So substituting in, we're going to get d dx of x sine x. Notice my correct use of notation as I go throughout. Is equal to u x times dv by dx, which is that. Putting everything into brackets, plus v, which is arc sine x, times du by dx, which is 1. Okay, and that will just come down to being x over the square root of 1 minus x squared over arc sine. Okay, now I could put this over common denominator, but that might not help me do the next bit, because notice here I've got an arc sine, and this is what I need to be able to find. Right, part B. From part A, I've got the differential of arc sine x is equal to x times the square root of 1 minus x squared arc sine x. So if I integrate here, I'm going to get arc sine x is equal to the integral of x over 1 minus x squared dx, which I'll need to work out, plus the integral of arc sine x dx. Now don't forget, I was trying to find the integral of arc sine x. So if I rearrange this and make this the subject, then the answer to this will be the combination of these two, as see. So rearranging, we get the integral of arc sine x dx is equal to x arc sine minus x times 1 over x squared minus a half dx. I've arranged it like this because it's easy to integrate. Now I'm going to suspect that this came from 1 minus x squared to the half. So if I differentiate it, just to check, see if I get back to what I started with, I'm going to get d dx, which is a half, write down the bracket, reduce the power by 1, and then differentiate the bracket. I've got a minus 2x. The 2's will cancel, so I've got minus x over 1 plus x squared. So this will be equal to x sine x. Now, because this is minus, okay, and this was positive, this will now be a positive. Pause the video if you're not sure on that fact. And then this integration will be my guess, which is 1 minus x squared to the half, which I'm going to write in square root form. So it will be x sine x plus square root of 1 minus x squared. And as it's an integration, we need to add in the constant. Please don't forget that. So this has been a video to show you how to differentiate x arc sine x, and then use that to find the integral of arc sine x. I hope you've understood, and I thank you very much for watching.